Next, unit 3, the spatial relationships. The spatial relationships are important in analysis. It can be a relationship between a point and an area. It's important to relating the object to the surrounding environment. So, in this regards, the intersections of the points between two lines. It's important to analyzing the routes through networks. In these relationships, it can be exist between the entities of the same types of different types. So for each shopping centers, it can be find out the nearest to shopping center at the same time. So this is a spatial relationship, which can be used for each customers can find the nearest shopping centers with the different settings. So the types of relationships is mainly broadly classified by three types. In these relationships, which are used to construct the complex objects from these primitives. Next, regarding this, the relationship between a line, chain, and the ordered set of points which defines its. In these relationships between the area, polygon, and ordered set of lines which defines it, then it can be a two lines can be examined to see if the cross by identification, the shared mode across relationship can be computed. The area can be examined and can see which one encloses a given point and then contained in relationship can be computed. The area can be examined if they overlap, the overlaps in relationships. In this overlap relationships, which can be computed from coordinates, these must be the coded in the database or during the inputs. Examples, we can compute the two lines, but we can use this cross lines in the highway. They represent the intersects. It can be maybe an some databases allow the entity called complex objects and composed by simple objects, and it can be objects representing the house. A lot cable with associated with attributes might be grouped together logical as a counter. So in this regard, we can use the two-line method and examine the two-line methods by means of the database structures. So next is the relationships between the computer frameworks from the coordinates, and it can be must coded in the database during the input. So in this database input, the point to point and point to point between the lines and point lines and point areas and line by line and then line areas and area by area lines. So in this point to point lines and point to lines and area and line to line and area to. So these are the major six examples, and it can be used for all customer points within the 1 kilometer of this retail store points. So in this, find the intersections at the end of the street. Find the road nearest to this aircraft traffic. In this point area, it contains find all the customers located in the zip code boundaries. It can be seen from some determinations of which can be taken from this new point by cross sections and determine if this road and crosses its rivers. Then it can be find all of the roads which come within the 1 kilometer of this wild roads and can be find out the stream flows in this river. Then the line area is crosses find all the soil types and it can be crossed by these wild roads. So these type of borders find out its road forms, what are the boundaries of this aircraft. So in this identifications of overlaps between the types of soil and types of land and it can be maps used. Then they find out the nearest lake to this forest fires and find out these two areas and then share common boundaries. So in this common boundary, there are different various types which can be used to point and point line and point area and line by line and line by area and area by area. So this point by point area within or nearest, and then the point line is online and nearest to the points. Then the point area is an in area and out area. That means in area and out area. Then the line by line area is intersections, and then cross sections and flow sections into the intersect border. And it can be the overlap inside adjacent stuff. So these are the topological relationships between the spatial objects. In other case, the topology can be relations to the spatial data and consist of three elements. This was a very important and major three elements of topology: adjacency, and then containment, and then connectivity. So after this containment and connectivity, the topology is, it can be a term used to describe the geometry characteristics and the objects which do not change under transformation, such as stretching or bending, and are dependent of any coordinate system. The topology characteristics of objects, it can be also independent of scale of measurements. In this topology, it relates to the spatial data. So these three major types, adjacency, containment, connectivity, we'll see the can be used in both cases, and then adjacency, containment, connectivity. So these areas can be described as being adjacent when they share a common boundary. For examples, the sky slopes and the car parks in Happy Valley, and it can be a maybe adjacent. The adjacency and containment describe the geometric relationships which exist between the area and then features. Then the containments and extensions are the adjacency theme and describes the area features which may be wholly contained within the another area. Features such as an island within a the connectivity. The connectivity is a geometric property. It can be used to describe the linkages between the line fractures, roads, and it can be usefully connected together to form a road network through which traffic can flow. An understanding of the geometric relationships between the spatial entities is important for analysis, and it can be integrations in GIS. Then the most common adjacency, containment, and connectivity, vectors and grids. The vectors and grids, and it can be explained connectivity is defined explicitly of the directed pointers between records, and it can be describing things that are linked in space. So these junctions between the roads, and it can be a grid topological properties, connectivity between the different locations, and it can be maybe only be implicitly defined by spatial rates, and it can be change of attribute values over the grid. The topology of the gridded surfaces can be revealed by computing fast the second or higher or derivatives to the surfaces. So these are the major and working principles. So in this regards, we have found out the vector and grid sections. Vector sections and grid sections. So vector sections are connectivity defined explicitly. Already we discussed about this point. So far in between the junction and then roads. And the grid system is defined as topological properties of connectivity between different locations may only be defined by spatial rates of change of attribute values over the grid. The topology of gridded surfaces can be revealed by computing first, second, or higher order derivatives of surfaces. So these are the basic terms of the elements of topological features. We have majorly it can be used and utilized. Then the other things of the major types we can be used in this topologies. The problem solving methods like the road systems and then congested area. It means the congested area means the variable areas can be divided into different levels and then forms a connectivity depends on the implicity of the direct pointer between records describing things that are linked in space. So these are the basic things that can be described, and then grid properties also we can be explained, and it can be used for the different properties. Can be the connectivity between the different locations, and can be only the simplicity values and spatial rates change attribute values. Or the topology of the gridded surfaces can be revealed by computing first, and then second it can be higher order derivatives of the surfaces. So these are the major things which will be used. And then the one more important point in this topic, the point to point line and then the area to area line. In first drawings, the point to point line is within the surfaces and nearest to surfaces. Then the area to area is defined as the overlap and inside the distances and adjacent to. Okay, so these are the things we have discussed today in this spatial relationship. So in this next topic, we will discuss about the raster and vector data.